So we are going to talk about another application of derivatives this morning, and it is curve sketching. So we've talked so far about a number of different applications, but this one allows us to sketch polynomial functions, rational functions, different types of functions using the derivative and the second derivative. So we've talked about the fact that if you think about a maximum or a minimum, the derivative is the slope of the tangent line at that point, and the tangent line is going to be a horizontal line. So if I take a function like this, then at a minimum right here, or at a maximum, it's supposed to be horizontal, but you can see that the tangent line's flat. And so we can, if we take the derivative, which is the slope of the tangent line, and figure out where is it 0, that will tell us where the maximum minimums happen, because that's where the slope of the tangent line is 0. So that's how we use the derivative to find the slope of the tangent. So we're going to do that, and then we can also use the second derivative to help us find other information. So this is going to help us draw curves that otherwise might not be very easy to draw. So with cubics, we know what quartics look like, and cubics look like, and quintic functions, all the polynomial functions. We talked about that last year. But when we did that, we talked just about the nature of the roots, and we found double roots and triple roots. So if we could, remember we did things like f of x equals, and then we would do, x minus 3 squared times x minus 2. And we knew that was a double root, and that was a single root, and we would graph by, if we go to, x equals 3, here's 2, this is very rough, but here's 2, here's 3, there's a single root there, and there's a double root there. We know before 2 it's going to be negative, so it kind of comes up like this, goes back down and back up. All right, and I know this is small and it's a rough sketch, but what we talked about last year, if you remember, is that we don't know where that is. We don't know what that max or minimum is. And now with derivatives, we can find out where that is. So the other thing we're going to look at is what happens if I can't even factor it, because some of them we can't factor at all. And so we don't know what the x-intercepts are. So it's easy to draw with the derivative even if we don't know what the x-intercepts are. So here's what we're going to do. We're going to use the derivative, first of all, set it equal to 0 and solve for x, and then figure out the max and mins. And to do that, you have to use a number line, and we'll talk about that in just a second. And then we're going to plot those points. Okay? So here's what you need to understand about max and min points. Maximums are going to occur when the function goes from increasing to decreasing. That is, it goes from going up to going down. So the slopes are positive on this side and negative on that side. The slope's a tangent line. Minimums are the opposite. So minimums go from negative to positive. And there's two different types of max and mins. There's local max and mins, and those are just, it's a minimum point within a small domain around it, so within a specified interval. The absolute max or min is the smallest or largest point on the entire function. So if there's a bunch of local minimums, then it might be the largest or smallest of those. It's also possible, and I've said that here, that this may not even happen. You may not have an absolute max or min if the function goes on to infinity. So for example, if you look at a cubic function, most of them kind of look like this in some measure. Well, there's a local maximum right there, and there's a local minimum right there, but there is no absolute max or min because it goes on to infinity. Okay? So that information right here, the plus, minus, or minus, plus, means if we jump back here for a second, when I'm talking about this number line, we look at what happens to the derivative and look at the sign changes. And we say, okay, if it goes from positive before where it's 0 to negative afterwards, it's a maximum. And if it goes from negative to positive, it's a minimum. And the other note that I've made is that you also have to consider when is the derivative undefined. Okay, we'll talk more about that when we get into rational functions. So that's the concept. So let's look at an example of that concept by actually doing this function. So we have 2x cubed minus 3x squared minus 2x plus 1, and I want to draw it. So the first thing I'm going to do is look at the first derivative. And the first derivative is 6x squared from that one minus 6x minus 2. Okay, now because we're already taking the derivative, we'll take the second derivative as well because we're going to use it a little bit later. So the second derivative is 12x minus 6. But we're going to look at the first derivative first. And the thing that we're going to do with it is we're going to set it equal to 0, right? We're going to try to figure out when is that derivative 0. So I take 6x squared minus 6x minus 2 equals 0. And I try to solve it. So the first thing I'm going to do is divide by 2 because they're all divisible by 2. So that's easy. And then I'm going to try to factor it if I can. You can't, so you put them into quadratic formula. And I'm not going to go through that. You know how to use the quadratic formula. But basically, you end up with two numbers. Okay? 1.26 and negative 0.26. All right? Now, once we do that, once we find those two numbers, then we put them on a number line. And this number line looks really confusing. And that's because it is. So we're going to try to look at one part at a time. So let's look right here first. We want to look at something that's less than 3 minus root 21 over 6, which we've discovered is minus 0.26. So if I just look at this interval, I want to say I need a number that's less than negative 0.26. So I picked x equals minus 1. Okay? To try to figure out what is the derivative, sign of the derivative, we don't care what the number is, but is it positive or negative when x is minus 1? So, okay, plug in minus 1 into my derivative and it comes out to 10. So it's positive there. Then I look at this interval. Okay, this interval right here is between minus 0.26 and 1.26. So I've got to figure out, okay, I need a number that's in there. So I chose, if you look right here, I chose x equals 0 to do that. And I plugged in 0, and when I plug 0 into the derivative, it's minus 2. So that gave me a negative, and then I looked at a number bigger than 1.26. So I looked at 2, plugged 2 into the derivative, and I got 10 again, so it was positive. So what that told me was the derivative goes plus, minus, plus. And then what I do, you don't need this little marker here, but what I kind of do is just say, okay, well, if I know it's going positive to negative, and then negative to positive, I can draw in what that means in terms of the function. So what I've done is said, okay, it's going from positive to negative. So that means it was going positive and then it goes negative. So that means I have a maximum. It's just kind of a visual way of seeing that it's a maximum. And if it's negative and then it goes to positive, then I have a minimum. Okay, so I know that this is a maximum, that's a minimum. Then I want to find the y values associated with those two numbers. And to do that, I plug the number minus 0.26 and 1.26 back into the original function because I want what y equals. So I say y is equal to this, okay, and I plug it in, and I get 1.28. And then I plug in, for the minimum, I plug in 1.26, and I get negative 2.28. So I'm just plugging in again. I'm going y equals, and then 2 times 1.26 cubed minus 3 times 1.26, and then minus 2 times 1.26, and then plus 1. And if you do that, you get negative 2.28. Now, that's just finding the 2 points. So I know now that there's a maximum here and a minimum there. And then the question is, when does the function increasing and decreasing? And that's based on my number line. So if the slopes are positive, it's increasing. The function is, not the derivative, but the function. So the function's going up until it hits that number. And so then it goes down, and then it goes back up. So if I notice the derivative is positive before minus 0.26 and after 1.26, okay? So there's my interval. It's from minus infinity to negative 0.26, which I'm writing as the exact value. Okay, that's why I'm writing 3 minus root 21 over 6. And then from 3 plus root 21 over 6, or 1.26, to infinity. And you guys are used to that interval notation. I think you should be. So then I look at, okay, what about the decrease? Where is it decreasing? And the decrease just is the negative part of my number line. So it's from 3 minus root 21 over 6 to 3 plus root 21 over 6. And again, that interval is there for you. Okay, so that's all the information you can get from the first derivative. And I'm going to do another video, I think, to show you what happens with the second derivative, and we'll finish on there because it's not all going to fit. These questions take a little bit of time. So I'm going to stop there. We'll start up with the second derivative in the next video.